Looking through the source material for this one, we're diving into what is honestly one of the most mind-bending, ambitious scientific endeavors in all of human history. We are talking about the literal pursuit of stellar power right here on Earth. Just take a second to process that. We're trying to take the exact mechanics that light up the cosmos and bottle them up on our own planet. It is an absolutely fascinating journey, so let's just jump right into the science.
Okay, so let's tackle this massive question right off the bat. Have scientists actually built a sun on Earth? I mean, when I first read that out loud, it sounded like pure science fiction, right? Like something straight out of a comic book. But the research we're looking at tells a very different, very real story. The reality here is that humanity is closer than we've ever been to recreating the exact same process that powers our sun, right inside our own laboratories.
To really grasp how humanity is pushing toward this incredible milestone, we need to break down the mechanics first. So let's look at section 1, nuclear fusion, understanding the science. So think about deep inside the sun. It's essentially this giant cosmic pressure cooker. The environment is just incredibly intense. You have these hydrogen atoms, and under extreme heat and extreme pressure, they don't just bounce off each other. No, they actually smash and fuse together. This fundamental reaction, that's what we call nuclear fusion. And the byproduct of these atoms fusing together, it releases enormous, almost unfathomable amounts of energy. Basically, we're trying to build that exact same cosmic pressure cooker in a lab, which, as you can imagine, is an engineering hurdle of epic proportions.
But you might be wondering, why go through all that trouble? Why risk so much time and capital? Well, that brings us to section 2, the ultimate prize. Why capture a star?
Here's exactly why fusion is considered the holy grail of power generation. Think about traditional nuclear power, the fission plants we've been using for decades. They're incredibly effective, sure, but we all know they come with a really heavy burden, long-lived radioactive waste. Fusion, on the other hand, operates entirely differently. If we can get this right, it provides nearly limitless clean energy with absolutely zero carbon emissions while it's running. Plus, it leaves behind dramatically less of that long-term radioactive waste. It's almost the perfect energy source. It could effectively solve our global energy crisis in one fell swoop. So, if it's so perfect, why isn't it powering your house right now? Well, that brings us to section 3, the catch, extreme temperatures. To actually make fusion happen, you can't just throw some fuel into a conventional furnace. Scientists literally have to heat the fuel to more than 100 million degrees Celsius. Let that number sink in for a second. 100 million degrees. That is roughly 6 times hotter than the core of our actual sun. We're trying to build an environment here on Earth that makes the blistering center of our solar system look like a mild summer day. The sheer extremity of the science required here is just absolutely staggering. Now, at 100 million degrees, matter fundamentally changes. It becomes something called plasma, this super hot electrically charged state of matter. But here's the ultimate brain teaser for you. This super hot plasma cannot touch any solid surface. If it bumps into the walls of whatever container it's in, it instantly cools down, which immediately kills the reaction. Or worse, it just melts the container itself. It's kind of like the world's most high-stakes, terrifying game of operation. You have to hold this volatile, incredibly energetic substance, but you absolutely cannot touch the edges. So how do you solve an impossible physics problem like holding something you aren't allowed to touch? Let's move on to section 4, containing a star, magnetic fields. The solution here is just an absolute masterclass in human engineering. It's this crazy high-stakes balancing act in 2 steps. Step 1, you heat the fuel until it turns into that volatile, super hot plasma. And step 2 is where the magic really happens. To control it, scientists suspend the plasma using incredibly powerful magnetic fields inside giant machines called fusion reactors. Think of these magnetic fields kind of like an invisible magnetic donut. This field traps the plasma, squeezing it so it hovers perfectly in a vacuum, never once touching the physical walls of the machine. For decades, fusion was kind of the running joke of the physics world. It was that technology that was perpetually 30 years away. But the source material shows a massive paradigm shift is happening right now. Researchers have finally achieved tangible, major advances in plasma control and actual net positive fusion reactions. And because the science is finally catching up to the theory, the money is aggressively following. Governments and private companies are pouring billions of dollars into this space right now. They're literally racing to get this technology out of the lab and onto our electrical grids. So, what happens if these giant billion-dollar machines actually succeed? Let's cast a vision in section 5, a clean energy future, transforming our world. If fusion becomes a practical, everyday reality, the implications are just staggering. We are talking about entire cities powered purely by clean, limitless energy. We're looking at millions of electric vehicles being charged by a grid that never suffers from shortages. And most importantly, we'd be looking at a society drastically unchained from fossil fuels. This technology has the very real potential to completely halt energy scarcity and completely rewrite our relationship with the environment.
So ultimately, no, scientists haven't put a literal glowing orb of fire in a room somewhere, but they are doing something arguably much more profound. They are mastering the literal force that powers the cosmos. And if they succeed in harnessing that force efficiently, it is honestly not an exaggeration to say it will reshape the future of humanity forever.
Which leaves us with a pretty provocative thought for today. Knowing what we now know about the extreme heat, the invisible magnetic cages, and the incredible promise of limitless clean energy, would you want a fusion reactor in your city? It's a technology moving incredibly fast from the realm of science fiction right into our actual backyards. The future is arriving fast, guys. Think about it. Thanks so much for joining me for this explainer, and be sure to check back for more breakdowns of the incredible science shaping our world.